All right, this is Algebra 2, Lesson 54, and this lesson covers polar coordinates and similar triangles. Rectangular coordinates. This is a little bit different than when we use the coordinate plane coordinates. These are called rectangular coordinates. We're going to use positive R for places that we go to the right, negative R for to the left, positive U for up, and negative U for down. It's really super duper easy. All right, so all I have to do for this is I'm going to count over. For A, I've gone to the right 4, and this direction is going to be positive, right? And that direction is going to be negative, negative R, positive R. And then up is going to be positive U, and down will be negative U. So for A, I've gone to the right 4 spaces. So that would be 4U, no, 4R, and I've gone up 3 spaces, so 3U. For B, I went backwards 3, so negative 3R, and then I went up 5, so let's see, it's positive. I'm going to put a comma in between those two. There we go. That would be 5 up. All right, C is going to be, I start at my origin, I go to the right 3, so negative 3R. I went to the left 3, so negative R. And then down 3, so negative 3 up. All right, and then D is going to be to the right 5 and down 2. Super easy. It's just another way of writing those. All right, the other way of writing them is called polar coordinates, and it's written in a form that looks like that. So we use a distance and an angle. The distance is measured clockwise from the line that normally designates the XY axis. So when we write it, it's going to look like that. So it's 4, and these are what's called a vector, okay? And if you have taken physics, then you've probably dealt with vectors before. All right, so that means that this line, this 4 right here, means that the length of this line is 4. Okay, that's 4 long. And then this 57 right here means the angle from there to there is 57 degrees. Okay, that's all that means. If we had, let's say, and we go counterclockwise. So let's say that we had another one. Write it on there. Let's say that we had 3 127. All right, so that means it's going to be 3 long, but it has to be 120 at the degrees 127. So if we go from here to here, that's going to be 90. If we go all the way down to here, that would be 180. So 127 is going to be about there. And then 3 long. So about that long. So it'd be somewhere like that. Okay? All right, so how do we change a rectangular coordinate, a polar coordinate, to a rectangular coordinate? Change 4 at 57 degrees to a rectangular coordinate. So first we're going to kind of draw it out. And we went, let's see, 45 would be right in the middle, so it's probably more like right there, and it's 4 long, and we got to figure out what it would be. All right, so what we're going to do is we're going to turn this into a triangle. So now we have a triangle. And we know that this part is 4. And this angle is 57 degrees. So we can use our trig functions to solve for both these sides. Let me zoom in here a bit. Alright, so if I'm going to use trig functions to solve for both these sides, I know that this one's my opposite, and this one's my hypotenuse, and this one would be my adjacent. Alright, so if we got SOHCAHTOA, alright, so we have the hypotenuse, so we need trig functions that will have the hypotenuse in there, like for example, sine equals opposite, that's this one, over hypotenuse, which is 4. Okay, and then cosine equals adjacent over hypotenuse, which is 4. Tangent we can't use because it equals our opposite over our adjacent, and those, we don't know either one of those, so we can't use that. Alright, so first for sine, we're going to say the sine of 57 degrees equals opposite over 4, and so we'll multiply times 4 and multiply this side times 4, so we need the sine of 57 degrees times 4, so we'll go to our calculator, and that is not an acceptable calculator. We need a scientific calculator. Okay, so we need 57 degrees, sine of 57 degrees, times 4. 3.354, so we're just going to say 3.35 is this one. So that's how much we went up, right? That's our up. Now we're going to figure out our over, that's our adjacent. So that would be the cosine of 57 degrees equals adjacent over 4. So we're going to multiply times 4 on both sides. So we need 4 times the cosine of 57 degrees. So we're going to clear that, and we're going to say 57 cosine. Okay, and then we're going to multiply that times 4. And we get 2.17. So that would be our adjacent right there, how far we went to the right. Alright, so we should have the right, we went 2.17 R, and positive 3.35 up. And in the book it says 2.16 and 3.36, so if you're off just a tiny bit, that just depends on whether you estimate before you multiply. So I'll count it right if it's close. Alright, so that's how you use trig functions to change a polar coordinate into a rectangular coordinate. Alright, here's another one. This one says change 7 at 230 degrees to a rectangular coordinate. So first we're going to draw a model of this. Alright, and we need 230 degrees. So right here's 90. There's 180. So 180 plus another 90 would be 270 right there. And we need 230, so it's going to be right in here somewhere. Okay. And that's going to go like that. And then we've got our triangle. So our triangle's down here. Okay, so we got to figure out what that angle is right there. It's not 270 because 270 would be all the way around. And we're not going all the way around. We just need what's inside this triangle. Right here. Okay, so that would be 270 minus, what's our angle? 230. So if all the way around is 270, and our part is just from here to here, right? Whatever's left is going to be this little angle. So we're going to say 270 minus 230. And we're going to get 40 degrees. All right, so inside our little angle there, we're going to have 40 degrees. All right, and then it said that it's 7. So that means that our hypotenuse right here is 7. All right, so this one would be our opposite, and this would be our adjacent. Okay, and we're always going to use sine and cosine. Sine equals opposite over hypotenuse because we always know the hypotenuse. Okay, the hypotenuse is the one that we know. And then cosine equals adjacent over hypotenuse. All right, so let's do the adjacent first so we can see our up and down value. So we could say cosine of 40 degrees equals opposite. Wait, nope, not opposite. Adjacent over 7. So then we multiply times 7 and we multiply times 7. And our adjacent is going to be the cosine of 40 degrees times 7. Cosine times 7, 5.36. So this one right here is 5.36, and that's our up and down. Okay, and then our left and right is going to be the sine of 40 degrees equals opposite over hypotenuse, which was 7. So times 7. You see a pattern here? You're always going to have the sine of 40 times whatever your hypotenuse is, the cosine of 40, the cosine of your angle times whatever your hypotenuse is. So I need the sine of 40 times 7. $4.499. That'll be this one, 4.49. All right, and we're going to come up with negative 4.49 R. So there's our negative R. And then negative 5.36 U. All right, so that would be the answer that you would write. All right, one more of these. Okay, so we're going to draw a little thing here to figure what our angle. That's 340. We know that if we went all the way around, it would be 360. So it's a little bit less than 360. So we're going to go 360 minus 340. We're going to get 20 degrees. So that is 20 degrees. All right, and this sticks way out. This goes 42 and then there's that. Alright, so our opposite is here, and our adjacent is here. Alright, so there's our triangle, and our angle is 20 degrees. So we're going to say sine of 20 degrees equals opposite over 42. So we multiply times 42 and times 42. And that's going to give us our opposite. That's going to be our up and down. Sine 20 times 42. $14.36. That's this one. Okay, our up and down. And that'd be negative. Alright, and then the sine of 20 degrees equals the adjacent over 42. So times 42. So 20 degrees cosine times 42, 39.46. That'd be that one. Actually, that would round up to 4.7. The book has 4.8. Alright, so our right would be 39.48R. And then we're going down, so that's minus 14.36U. And there's the answer to that one. These are actually pretty easy if you understand the trig functions. Alright, similar triangles. So when we look at this triangle, we can see that two of these angles match up. This one matches to this one. Okay, so we can write a ratio with this. So I'm going to say C, I'm going to put that on the top. It's opposite, equals D, I'm going to put that one on the top. Alright, and then the one in the same triangle with the C is the A. And the one in the same triangle with the D is the B. Alright, so if I wanted to solve for, let's say I want to solve for C, I've got C over A equals D over B. I can just cross multiply these. AD equals BC, and then I'm solving for C, so I just divide by B, and I get C equals AD over B. Super easy. Alright, go ahead and work the practice problems. I'll pause the video, and then I'll come back and work them for you. Alright, so this first one, we've got 28 at an angle of 310. So if you make a little mock-up of this here, 310, we've got, that's 90, that's 180, that's 270, 360 will be all the way around. So the closest one is 360. So I'm going to say 360 minus 310. And I'm going to get 50 degrees. So it's going to be 50 degrees that way. And this is going to be 28. Alright, and then this is 50 degrees. So our opposite is here, and our adjacent is here. So we got sine of 50 degrees equals our opposite over 28. So we need the sine of 50 times 28. 21.45. So that's our opposite right there, 21.45. And then we need our adjacent, so the cosine of 50 degrees equals our adjacent over 28, multiply times 28 on both sides, and we get cosine of 50 times 28, 17.99. That will round up to 18. We might as well round that up to 18 there. Alright, so we went 18R, and then we went negative 21.45 up. And that's the answer to that one. Pretty easy. Alright. Next one, the two triangles in this figure are similar. Use R, S, T, and V to write a proportion, then solve for R in terms of S, T, and V. Alright, so I've got two angles that are similar. So across from this one's going to be my R, and across from this one's going to be my T. So I'm going to put my R on top and my T on top. Okay, then with the R is the S. Put that on the bottom. And with the T is the V, so I'm going to put that on bottom. Okay, so there's my proportion. And then I just got to cross multiply, so I get ST equals RV. And I'm supposed to solve for R. So I'm going to divide by V. And I get R equals ST over V. And there's the answer to that one. Those are really easy. Alright, that's it for the practice problems. Thank you for watching. Have a good day.